for scale 6, it's all, oh, Colin, you gonna make it? It's all about calculating trig functions for any angle, okay, not just our special angles. Now we use the unit circle for the special angles. That's the 30, the 45, the 60, 0, 90, 180, 270, 360, okay, those are our special angles. And we use the unit circle for those because it has a radius of 1, making all of the ratios in their most simplified form, okay, and we talked about that 2 weeks ago or so. But what if it's not a special angle? Eek! No solution. Nice try. No, there's just a different way to approach it. So take a look at example number 10 with me, please. It says if the sine of theta is 3/5, if cosine of theta is -4/5, find the remaining 4 trig functions. Okay, so right away I know that I'm dealing with right triangles because these trig functions don't apply to any triangle other than a right angled triangle. Okay, I'm going to draw my axes because I need to figure out what quadrant this triangle is going to go in. Okay, now remember, this is all trig functions being positive, sine and its reciprocal, tangent and its reciprocal, cosine and its reciprocal. All students take calculus. No, they don't, but it helps us remember anyway. Okay, so the first requirement is that sine is positive. Well, that cancels out the third and the fourth quadrant. Sine is only positive in the first and the second. The second requirement is that cosine is negative. Okay, so immediately the first quadrant's out because all trig functions are positive in the first quadrant. So the triangle that we need to draw that exists for the given information is going to lie in our second quadrant. So I'm going to draw my triangle with the reference angle at the origin. Friendly reminder, if I were to rotate an angle in standard position, the hypotenuse is the terminal side. We always drop the altitude to the x-axis, whether it's down to the x-axis or up. And the reference angle is always at the origin between the terminal side and the x-axis. So what does that mean for our triangle? The reference angle is always between the hypotenuse and the x-axis. Okay, so now that we have that established, look at what we know. We know that the sine of theta is 3/5. So that means the opposite leg from my reference angle is 3, and the hypotenuse is 5. Okay, well, we also know that the cosine of this same reference angle is -4/5. So that means the adjacent leg is -4. Now we have to stop and think for a second. Does this make sense in the second quadrant? Should our adjacent leg be negative? Should the opposite be positive? Colin's nodding yes. Yeah, absolutely it should. It's just a nice little self-check to make sure that you drew the triangle in the correct location. Okay, so let's find the remaining 4 trig functions. We were given sine and cosine. That leads us to tangent. So tangent of theta is the opposite over the adjacent. So I'm going to say it's -3/4. Even though the 4 is negative, it's more proper notation to have the negative at the numerator. You're allowed to do that. And then our reciprocals. So the cosecant of theta is the reciprocal of sine. That leads us to 5/3. The secant of theta is the reciprocal of cosine, which leads us to -5/4. And then the cotangent of theta is the reciprocal of tangent, which leads us to be -4/3. And we're done. So a little detective sleuth work, and then we were able to answer the question. Let's take a look at number 11, as it is quite similar, and then I'll take questions if you have them on these two. So number 11 gives us a positive tangent and a negative cosine. Okay, I'm going to go ahead and draw the axes again so I have a visual aid here. And this is all trig functions, sine and the reciprocal, tangent and the reciprocal, cosine and its reciprocal. First piece of information is that tangent is positive. Okay, so that means the second quadrant is out, as is the fourth. My triangle does not exist there. Cosine is negative. That's the second piece of information we were given. So then the first quadrant's out because all trig functions are positive there. That means our triangle exists in the third quadrant. I'm going to draw my triangle out with the hypotenuse attaching to the origin, reference angle at the origin between the hypotenuse and the x-axis, and the altitude attaching to the x-axis as well. Okay, tangent of theta is 5 over 12, so that means the opposite leg is 5 and the adjacent leg is 12. But think about where we are. We're in the third quadrant. What do we know about x and y in the third quadrant? Anybody?
Both negative.
They're both negative. Dean, were you going to say that too? Sorry, other Dean? Yeah, nice job, Deans. Dean squared. Ah. All right, stupid math joke. Anyway, excellent, gentlemen. Yes, they're both negative. So the 5 and the 12 need to be negative. Really important you check your axes when you draw your triangle. All right, now cosine is negative 12 over 13. So that makes sense. The negative goes on the 12. And then our hypotenuse is 13. So let's find the other trig functions. We have cosine and tangent only, so let's start with sine. The sine of theta is going to be the opposite, which is negative 5 over the hypotenuse, which is 13. We have cosine, we have tangent. Let's jump to our reciprocals. We have the the cosecant of theta, which is the reciprocal of sine, so negative 13 over 5. We have secant of theta, which is the reciprocal of cosine, so negative 13 over 12. And the cotangent of theta, which is the reciprocal of tangent, grand finale, 12 over 5. Yay! So for these, you first have to figure out where you are with relation or in relation to your quadrants. Draw the triangle always with the reference angle between the hypotenuse and the x-axis, and then fill in the remaining pieces that were given. Any questions on 10 or 11 before we journey to 12? Journey on, let's do it. Example number 12. Ooh, this is different. Yeah. Okay. If a terminal side, so that is our hypotenuse, right? If the terminal side of an angle passes through a point on a circle, and the point is 8, negative 15. Okay, so 8, negative 15. We need to find all 6 trig functions. Challenge accepted. Let's draw the axes. Here's my y-axis. Think about the coordinate. Positive 8, negative 15. Okay, go a little old school with me back to Algebra 1. I think pre-algebra, actually, when you learned how to plot points. I would go over to the right, positive 8, and then I would go down negative 15 units to get to that coordinate. And the terminal side, the hypotenuse, would connect to the origin. Okay, so when it says a terminal side of the angle passes through the given point, that means that from the origin to that point extends our hypotenuse. You just have to figure out where the point lies. All right, well, there is a small, eensy-weensy little problem, and that is I don't have a hypotenuse. How can you find the hypotenuse? Nadia? Yeah, Pythagorean theorem. Very nice. So let's take 8 squared and add it to negative 15 squared and see what we get. Is it 289? Anyone? I got 289 in my head, but I need confirmation. No, Shannon, that's the final answer. Is r squared what? Oh, thank you guys so much. Okay, so it is 289, but if we take the square root of that, Shannon is correct. It should be 17. Now be careful, you guys, because the hypotenuse is representing distance. We would not have a plus and a minus option. Okay, it's only positive. Now, if you looked at this and you said, wait a second, that's a triple, 8, 15, 17. Do you need to use the Pythagorean theorem? No. But if you're not comfortable with the triples, because maybe it just didn't stick or your teacher didn't emphasize it or whatever, it's nice to know that you have the Pythagorean theorem that you can always use. Dean?
What are triples?
Oh, triples are your special right triangle sides that always exist. So 3, 4, 5. This one, 8, 15, 17. There's also 24, 27, 24, 25. So they're just side lengths that always exist in a right triangle, and they're just called the triples. Okay, thanks for asking. All right, you guys, let's find the 6 trig functions using our reference angle that exists between the hypotenuse and the x-axis. Yes, I've said that a lot, but it's because it's super important. Here we go. The sine of theta should be the opposite leg over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. Jumping over to our reciprocals, cosecant is the reciprocal of sine, leaving us with negative 17/15. Secant is the reciprocal of cosine, leaving us with 17/8. And cotangent is the reciprocal of tangent, which is negative 8/15. And we are done. That's it.